let's see this problem here. 1 1 1 a b c a square b square c square, but you have to remember this as a result after getting the answer. Just see how we are solving this problem. You see 1 1 1 a b c a square b square c square. Once again I am doing what, simply I am doing these two elements as zeros. Okay, how means indirectly r2 tends to r2 minus r1 and r3 tends to r3 minus r1. Simply that is 1 minus 1 1 minus 1. By using that we are doing these two elements as zeros. That is first row is not going to be changed, 1 a square. Next r2 minus r1, r2 is 1, r1 is nothing but 1, 1 minus 1 is going to be 0. Next b minus a, next b square minus a square. Here 1 minus 1 0, r3 minus r1, c minus a, c minus a, c square minus a square. From the formula we know that is a square minus b square is nothing but a square minus b square is nothing but a plus b into a minus b. From that here b square minus a square is there, 1 a square. Here 0 b minus a, here b minus a into b plus a is there. Here 0 c minus a and c minus a into c plus a is there, c square minus a square. From row number 2, from column row number 3, we are taking b minus a here and c minus a here. That is going to be b minus a into c minus a. That's from b minus a from row number 1 as it is row number 2, 0 1 b minus a taking common, that is 0 నుంచి b minus a 0 1 b minus a పోయింది, that is going to be b plus a. Here 0, next here 1, here c plus a. If I expand this determinant by using row number column number 1, what you will get answer here, that is going to be b minus a into c minus a, b minus a into c minus a, 1 into determinant of this matrix, that is AD minus BC. AD is nothing but 1 into c plus a minus BC 1 into b plus c minus b minus a, you will get next minus 0 plus 0, you will get 0 indirectly. Here see what I am doing means from b minus a I am taking minus common, a minus b, that is c minus a alane undi. Next here plus a minus a cancel, that is going to be c minus b. If I take minus common from here, this is going to be minus into minus plus a minus b. Next here this is b minus c, then after c minus a. This is going to be your result, that is a minus b into b minus c into c minus a. See, sometimes this question is going to be asked. See, we have one property, that is what determinant of A transpose equals to determinant of A. అంటే ఒక మ్యాట్రిక్స్ ట్రాన్స్పోజ్ చేసిన determinant సేమ్ ఉంటుంది. Based upon that he will ask the question is like indirectly he will write, he will transpose the elements. I am writing column 1 as a row, that is 1 1 1 A B C and a square b square c square. This is also equal to this matrix, and one more we can write instead of this a square b square c square, 1 1 1 a b c. Next here a square means bc ca ab. For this one also you are going to get same answer, that is a minus b into b minus c into c minus a. Here like this, here it is a result by following the procedure whatever just we discussed. If you follow that you are getting this answer, or simply if you having like this, if you remember this as a result, I can say this as some important results. You have to remember this important results, that is a minus b, b minus c, c minus c, the corresponding to the answer. Okay, here ask one more result I am going to give here, that is 1 1 1 A B C A cube B cube C cube. In place of A square B square C square we got A cube B cube C cube. The answer is going to be A minus B into B minus C into C minus A into A plus B plus C. A minus B into B minus C into C minus A into A plus. Same answer. We are one more thing we extra we got, that is A plus B plus C. One more result I am giving here. One more result I am giving here. That is a 1 1 1 A square B square C square A cube B cube C cube equals to A minus B into B minus C into C minus A into AB plus BC plus CA. These are the very important results, so many times asked in a competitive exams. If you remember this, it's quite enough. And also easy to remember. And one logic I am going to give here you people to remember these problems or results here. See, observe here. These are principal diagonal elements. The degree of C is square. The degree of B is 1. Nothing is there. 1 is nothing but we can say A power 0. Can we say like this? A power 0 is going to be 1. Like that. Here the degree is 0. Here degree is 1. Here degree is 2. If you add these 3 degrees, 0 plus 1 plus 2 is nothing but 3. Resultant answer degree is also 3. 1 1 1 if you add 3. Why? Because what I am saying going to say is, if we give this problem, if we mention these options, 3 options in the answers, options 3 answers options లో ఎగ్జిస్ట్ అయ్యాయి, అప్పుడు కరస్పాండింగ్ ఆన్సర్ ఏందనేది మర్చిపోతాం. కరస్పాండింగ్ ఆన్సర్ గుర్తుపెట్టుకోవడం కోసం నేను ఈ లాజిక్ ఇస్తున్నాను. నేను మీకు ఏంది డిగ్రీస్ అనేటి ఏదైతే క్వశ్చన్లో ఏదైతే డయాగనల్ ఎలిమెంట్స్ డిగ్రీస్ ఏవైతే యాడ్ చేస్తూ వచ్చినాయో ఆన్సర్లో కూడా అదే ఆన్సర్ డిగ్రీ ఉంటుంది. లైక్ సేమ్ ఇఫ్ యూ సీ here 1BC cube, if you see, that is 310, that is nothing but 4 1 1 1. Here A plus B plus degree is going to be 1. 1 plus 1 plus 1 is nothing but 4. If you see here 1 B square C cube is nothing but 5. 1 1 1, here AB is there, that is degree is 2. 2 plus 1 plus 1 plus is nothing but 5. The degree is going to be, అంటే ఇండైరెక్ట్లీ క్వశ్చన్ని కరస్పాండింగ్గా ఆప్షన్ అనేది మ్యాచ్ చేస్తున్నాం. లైక్ ప్రీవియస్ ప్రాబ్లమ్ వి గాట్ 1 మైనస్ ఏ స్క్వేర్ ఏబి ఏసీ AB minus B square BC AC BC minus C square, diagonal elements minus A square minus B square minus C square, like previous. That is 10th problem. What you got answer? 4A square B square C square. Degree diagonal elements degree 6. Answer la degree kuda 6. We can say perfect square also, that is us. Perfect square అని కూడా అనొచ్చు. 4A square B square C square అంటే 2 into ABC whole square. Like that, if you remember, it's going to be good for your health, right? If you see, based upon these results are going to be asked in your exams, I'm saying, but he won't ask directly. He will give in logically, that is, for suppose I'm writing here one question here. See, if D1 equals to 1 1 1 ABC A square B square C square, and D2 equals to 1 1 1 ABC BC CA AB, then first option D1 plus D2 equal to 0, second option D1 equal to D2, third option D1 equal to 2D2, fourth option none. If you don't know these results, you can't answer these questions. See, given this matrix and this one, that is transposed to that. A transpose always is going to be, we said A transpose always is going to be, determinant is going to be same matrix determinant. అంటే ఈ మ్యాట్రిక్స్కి ఈ మ్యాట్రిక్స్కి రెండింటికి సేమ్ ఆన్సర్ ఇదేనా? సింపుల్గా అప్పుడు ఆన్సర్ ఏమవుతుంది? D1 ఈక్వల్ టు D2. Yeah, like this, indirectly based upon these results, we'll discuss one more problem here. Let's discuss the other problems here. Okay, let's see. But you have to remember this all results. This is 1 and 2 and 3 and corresponding. We can write this one also like this. This one also like this. Okay, you have to remember results. So many results you are going to get in a matrix. But you have to remember this result. That's a very important result. So many times asked in ECET. Okay, let's see more problems. Let's see this problem. See, if A equal to B equal to C, then you given this matrix. Actually, this is asked in ECET 2011. See, this one equal to 0 and this is the condition. I am modifying this. This is a cube minus 1. A cube separate to minus 1 separate. This is 3 by 3 matrix. See, in our determinant we have one property, that is any row or any column having addition of numbers, 2 numbers, we can represent this matrix determinant as addition of 2 matrices. For suppose here place is there, or any row or any column, for suppose in single row, first row lone a plus 1, b a square plus b, b a cube minus 1, appudu inko 2 matrices ka exist cheyochu. Right, here by using this column, I am splitting this matrix as 2 matrices. One is A, B, C. Next A square, B square, C square. Next A cube, B cube, C cube plus A, B, C, A square, B square, C square minus 1, minus 1, minus 1. But here I am not writing minus, just I am writing here. That is taking minus common, you will get this matrix. In between we having minus. See, in this matrix, I can take A common from row number 1, B common from row number 2, C common from row number 3. If you write that, it's going to be A, B, C, 1 A square you will get here. 1 B square you will get, 1 C square you will get, minus. If I interchange these 2 rows, column 3 place la column 1 place la column 3, 1 1 1, A square, B square, C square, A B C. This matrix is going to be multiplied with minus. Once again I am writing here this only ABC, 1 1 1, ABC, A square, B square, C square, already minus into minus plus. Here I am interchanging these 2 rows, that is 1 1 1. In place of A square we have to write A, B, C, A square, B square, C square. But interchange చేసినప్పుడు minus తో multiply చేయాలి. From these 2 values, this is a number, this is also number, right? I can take this value as directly common, that is 1 1 1, A B C, A square, B square, C square. If I take common, here we having only A B C, that is A B C. Here plus into minus is going to be minus 1. This value what he is saying equal to 0, we can equate to 0. Now this value already we said A minus B into B minus C into C minus A into A B C minus 1 equal to 0. See, the equation meaning is what? It may be 0 or it may be 0 or it may be 0 or it may be 0. If you take A minus B equal to 0, that is going to be A equal to B. If you take this one as 0, B equal to C. If you take this one as 0, C equal to A. But given what? A not equal to B, B not equal to C, C not equal to also A. That means indirectly this condition not satisfied. Only this is going to be A B C minus 1 equal to 0. Compulsory A B C equal to 1 only. It is not, these values are not going to be always ABC equal to 1. Here we having ABC equal to 1. For suppose, if you having here plus, you will write here plus, you will get here plus, indirectly minus, plus into minus, minus, then after minus into plus, minus is going to be plus, you will get ABC plus 1 equal to 0. If I am saying one more problem, not this problem, and whatever the value is there, this is interlinked in this problem. Just to say that one, just I given, always you won't ask this value directly, indirectly you may ask, you have to identify that. Understanding my point? This is the total concept of determinant of a matrix. You have to go through with this total concept. Like these problems you may get here minus 1 plus 1 would exist అయ్యే అవకాశం ఉంది. But one more problem indirectly you will get ABC equal to minus 1. This is indirectly if I am discussing this problem is one more problem already discussed, like that you have to think. Right, this is the total concept of determinant of a matrix. Always you have to remember, and determinant very important is cofactors and minors. These two parts, right, cofactors and minors. And then after determinant shortcut, determinant value how we are finding, we are discussing. And after that indirectly I given two equations to represent 2 by 2 matrix and 3 by 3 matrix, that equation. Then after the properties are very important properties, property based చేసుకొని number of problems. To give you examples to the property, I'm said this all number of problems. The properties are very important, and some more results are there. You have to remember that results, and singular matrix and non-singular also very important. You have to remember this also. This is the total concept of determinant of a matrix. From this also you are going to get one question compulsory, you will get in ECET 1 mark. Okay, let's in our next session we'll discuss other topic. Okay.